prepared before the class. And secondly, we try to do this logging technical classroom in which each and every groups will have different classes, and we will try to do this logging today so that by the time you guys start your technical training, you guys are already in place in the classroom. And thirdly, I plan to do a especially for the slot fundamental and also for the Raspberry Pi and also for the 3D design. If you guys don't have the software, I would like to encourage you guys to have it installed. So by now, if you notice in our WhatsApp group, MBEC and is requesting for your mail address. This is because for slot number 1 and for group number 1 Arduino and also group number 2 group number 3 Raspberry Pi, you guys will receive kit. They call this as Ninja Kit, in which in the kits there are several electronics components and microcontrollers and also Raspberry Pi unit for you guys to do the exercise. So towards the end, we will have a summary and last takeaway before the technical classes begin. Okay, as mentioned just now, today is a briefing session, basically to give you an overview, and if you have any questions, if you can try to address that and to get you guys prepared for the technical training. The technical training will take place beginning on in 2 weeks' time, Friday, on the September 11th and until September 13th. You will be 3 groups just now. The first one, Arduino, Raspberry Pi, and also 3D. This class will be conducted in parallel. So which means that you guys can only attend one slot per time, one class per slot. Okay. The classes will begin around 10 and will end around 12:30, and it will continue from 2 until 4. Right? Okay, so basically, yesterday, thank you for sharing your YouTube channels. I find it is very interesting, and I had browsed to several of the YouTube channels. I just haven't got the time to subscribe to your channels. But it's interesting to see you guys already delve into electronics project and also doing projects for competitions and so on. So basically, I think this digital making has been with you guys, and would just like to ask, what do you understand from the word digital making? Any
pembuatan digital. It's just like making what on earth is it? The production of products or prototype in a digital method.
Okay, when you mention digital method, what does digital method you understand from the word digital method?
3D printing.
Use tech to create something.
To create something. Tech.
Printing.
Technological advancements.
Using
technological advancement. All right. Okay. So nice. Technological advancement. Okay. If we look here last time, I mean, in the 1800, people used to use very conventional way of doing things, but at that time it was very advanced. Okay. So yeah, digital making. Well, if we were to look into the broad description, it says project that require technical skills and understanding. So when what you mentioned just now are correct in a way in which it require a certain understanding of technical knowledge. Now, during my time, all these sort of like electronics component and so on is not accessible when we are young. But now, as young as standard 5, standard 6, you guys can explore because of two things. Because of two things. The first one is that the electronics component become cheaper. Okay. Last like computers ranging around 10,000 and above. But now the mini computer like the Raspberry Pi that you guys will be having this kit is around 70 ringgit, 80 ringgit, the smaller size. So that you guys to build and to do prototype regardless where you are. And secondly, information is available online and also in an open source environment, which make it easier for you to do self-learning. Okay. basically, we are from UMP, University Malaysia Pahang, and in UMP, we view digital making skill set as a skill set that you need to require into a couple of cluster. We divide this into a couple of cluster. The first one is programming. The second one is design. Okay, when you mentioned just now like 3D design and so on, okay, there is this one word called as rapid prototyping, in which it is interrelated to the manufacturing. I will explain later how does it intercorrelate. And the last one is physical computing. Okay, so let me start with I think out of that four, the easiest part, programming. When we mention programming, what does programming means?
Mengatur caraan.
Okay, direct translation is pengaturcaraan. But what does programming, what do you,
Giving orders to the
To give-
robot.
you give
Type
orders?
command.
Okay, good.
Instructions.
Instruction, okay, set of instructions or
Controlling the device through languages.
controlling the device through languages, okay? So we have the word control, we have the word instruction, we have the word device. Okay, lagi some more?
There's some very common programming apps such as programming language such as JavaScript, Python, C++.
Okay, so just now Aaron mentioned about when we talk about programming
Teacher?
language. Okay, lagi? Sorry again, who was talking just now? Is it Jiva? What did you say?
Yeah, I'm Jivan Raj. Yeah, I mean,
Yes.
it's
What-
a processing process of designing. Process of designing.
okay,
I think.
okay,
What programming?
okay. Okay, process of a designing. Does every design or do every design require programming?
Not really lah.
Exactly.
Okay,
Not necessarily.
not necessarily. Okay,
Yes.
might be. All right.
Yeah.
Okay. So, all right. The best way to describe programming is I like the word instruction just now. It's about giving instructions. Okay. So wait, when we talk about programming, people always relate programming with computer. You always do the language. You always type something, and that typing has syntax and has languages. Just now, like I mentioned just now, we have like Python. We have like some other languages such as Java. That is a language, yeah. And then you guys also mentioned about robots. Okay, when you do robots, there are Lego-based robots, there are Arduino-based robots, and there are a couple of more kinds of robots. Okay, that is also another way of giving instructions to devices. Okay, so in an amateur level ataupun in the beginning level, what is expected for you when we mention about you need to acquire the programming skill is actually to give basic programming construct, or another way to be able to give instructions regardless whether it's to the computer or it's to the microcontroller or microprocessor. Simple instruction. For example, when you build up your Arduino project, such as the one, I couldn't remember whose, but the one who do this humidity sensor and so on, when you give instructions to the microcontroller to take the readings from the humidity sensor and process it a bit and give the output, okay, that is basic instructions. Okay, as you grow and as you will come across into projects that require a bit more complex rather than just to take the data and to display. Okay, for example, there are complexity that is involved. Say that how can you make sure that the humidity sensor is functioning at the right phase ataupun does it taking the right information, and are you displaying the right information at the right time? Is it in real time, and so on. Okay. So a matured programming skill, an expert who has this programming skill is the one that could do higher order programming technique, okay, to solve real world problems. Yeah, are you saying something just now?
Teacher? Yeah. But upon me, I think programming is a teacher know about binary code, the 0, 1.
Oh, 0, yeah.
So it also
yes.
including in programming, right? Because yeah,
Okay.
if in the computer also, if I want to, if I want to mute the microphone, I touch it.
Okay.
It also the yeah.
Yeah,
Yes, continue.
sorry. What's your name again? Sorry. Sorry.
No, programming in binary.
Yes, yes.
So can you
I
hear me?
in binary. Can I know your name, please? Sorry.
Jivan Raj.
Jivan. Okay. All right.
Jivan
So
Raj.
you mentioned just now is different programming level, not in the sense of different programming skill. Okay, you can program something by having syntax. Syntax means higher level of programming, such as when you do C programming or when you do Arduino programming or Raspberry Pi programming, we call that term as higher level programming. You can also go for a low level programming. Low level programming means you're talking machine to machine programming. So this is where the binary codes come in, okay? In the end of the day, your computer or your microprocessor will read 0, 1 signals. That what make it possible to have electronics to control equipment and so on. You will learn this in detail if you were to take, I think in your Asas Science Computer, they have this introduction on the binary, but how it interrelates to the computer and so on is it involve a couple of layers of programming. All right. So is
Okay.
the differences and also the level of programming. So typically when say for example, if you want to work as an engineer, I take an example in a microprocessor company, they will have a couple of layers. For those who do designing at a very lower level, at the very hardware physical level, it will always involve that binary form kind of programming. Okay, so but if you are focusing into applications and so on, typically we'll go for higher order programming. Not higher order in this sense, but higher order in we call this as high level programming, such as C programming and onward. Okay, so this is an example of a simple programming, which means that something to do, like I mentioned just now, just to take an information, to do a little processing, and then to display that information. So when you grow and when you come across a bit of complex, and when you see complex problem that you want to solve and so on, it will always involve this one tail. We call this as decision. Decision meaning that when you do something, the system can respond based on the situation that is happening. So this is, we call this as another level of programming skill. Okay, have you heard about machine learning or deep
It's like
Yes.
or artificial learning, artificial
Yes,
it's like a charta alert.
yes. This is Chata flowchart.
Yeah.
By the way, typically to make an initial attempt to solve ataupun to create a code before they go into detail. Okay, so those artificial intelligence, machine learning, and so on, this consists the same thing. Cumanya it is in a level that is very detailed and very complicated. Okay, but can be done. Okay, these all things can be done in a couple of layer. It can be done via Arduino, it can be done via Raspberry Pi and so on. It involves languages and so on. You can also do this in Java platform depending on the application that you want to address. Okay, the second tier is design. Okay, when we talk about design, a beginner ataupun at the fundamental level, visualization of 2D and 3D shapes is important. Okay, for example, if you were to look at a car, if you were to dissect the car, how will it look at the XY plane and also YZ plane and so on? Okay, and then from there, grow into how to design much more finished product ataupun finished complete object. How can you draw it and how can you display it? So that is another level. And the other one is how can you integrate multiple components into the design. Okay, let's look into this one example. When you want to draw, say for example, a human, okay, we can always start with this stickman. Okay, this is actually a little bit advanced from the stickman. If it is like conventional stickman, it always have like a head, 2 hands and 2 legs. Okay, but now it has a couple of limbs and so on. So when we want to go into a bit of the detail, you know that each and every part has the muscles and has another component, has other components, right? A finished product, at the end product, it will be something like this, which is near to the real object. Okay, same as if you were to start to draw a car. Okay, ability to sketch. This is an ability, maybe like 3 to 4-year-old children and so on, when they want to start to draw a car, it always have like, okay, a car will have 2 tires and will have a body, will have window and so on. So as you go into depth, you will see that you need to have this, each and every component to have at the right ratio. Then only it can resembles rightly, ataupun it resembles correctly the object. So then when you want to go to a finished product, then it comes into the surface. What kind of surface should the car has and so on till the end. Okay. Even though this is like sketch, but the level of sketching requires different skills. Before the MCO, 2 weeks before the MCO, I had the opportunity to visit Dream Edge, a company that is being assigned to develop our third national car. So we went to this department, one department. The only task that that department need to do is just to model the steering of the car. But it involved like 3 to 4% because they need to go up into the detail that is required for visualization and so on. Okay, right. Okay, now comes to the part of physical computing. Have you heard about this word before? Just now,
Yes.
Yes.
I mentioned.
Yes.
Okay,
We heard about
so
it.
what is physical computing?
Komputer fisikal.
The transistors.
Pengkomputeran fisikal.
That is direct translation. Okay. Just now, Jiva mentioned about 1010 thingy, right? That has something to do with this physical computing.
Transistors, maybe.
So, sorry, Amar, again? What is physical
Yes.
computing?
Something related to transistors.
Okay, all right. Something related to transistors. What do you guys think about physical computing? Personal
Electrical components.
physical component. Okay. If we talk about programming just now, it involves like you integrate the computer, kan? Okay, so now we're saying computing. Yes, okay, sorry. Are you saying something? Sorry?
It's a physical even in my physical programming computing, it's a creative framework like for how like human understand it.
How human understand computer?
Sure.
Okay.
Maybe interaction between computers. Maybe.
Okay.
Yeah.
Okay, interaction between computers. Okay. All right. So physical computing is a system that could interact with environment. Okay, with the environment. Okay, I have an illustration example after this, but let me go through the definition of basic, intermediate, and also advanced skill in this physical computing. I bet you have already come across with Arduino, Uno, Nano, those platform, Raspberry Pi. Have you seen this before?
No.
No, okay. The one that mentioned just now, you did project with robotics and so on. What kind of platform did you guys do? Ataupun what kind of robots did you guys deal with?
Arduino?
Cikgu, can I share my
Arduino?
experience?
Mine is Arduino.
Lego? Sorry again? What is Arduino?
My RPT, we had a section we
Arduino.
can do the Arduino coding to make the Arduino to roll into roll.
Okay. You mentioned the word RBT just now. If you are from primary school, Reka Bentuk Technology, okay. Some schools, they adopt this Arduino to do this project and so on. Some schools use microbit. Have you heard microbit before?
Yes.
Yes.
No.
Yes.
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 No.
It's like a
alright.
version of Arduino.
Yeah.
Okay. It's actually not a version of Arduino, but something a microcontroller as well. Something like it can do whatever Arduino do. The only thing is that it simplifies the process of programming because it has the microbit block programming and so on. So those Raspberry Pi, Arduino, microbit, and
No.
okay. Yeah, are you saying something? No. Okay. So those are the elements that we call it as basic electronics and basic electromechanical component. which means that when you have your microcontroller, you are able to control something. It might be control motors, it might be control display, and it can also read ataupun take values from sensors. Okay, wait, I think someone is coming in. Okay, Lego Mindstorm, yes. Lego as well, okay? So, when we talk about skill in physical computing means you are able to do basic programming, basic instruction, giving instruction to these controllers, microcontrollers, microprocessors to take value and also to give to display value. So an advanced, a little bit advanced version is where you can process the input. Meaning that, for example, if you want to do temperature reading and so on, so you can do a system that can take temperature and display. Say, for example, today my temperature is 36.4, okay, something like that, and it can display 36.4. You can also do something, say, for example, am I having a fever with this temperature or is it normal in this environment, Malaysian environment, room temperature with this kind of human body temperature? Is it normal and so on? You can do that kind of processing and give decision. Okay, that is the second tier. And the third tier, that you can make automated system. Okay, the second tier here, when we talk about process data input and so on, basically here it involves the, if you remember when we talked about programming just now, the one that is having this flowchart of decision making. So it involves here, but in a very, not to say complex, in a very, a little bit advanced version from the first one, which is only to take and display value. But then when you have a automated system, it can react to the environment and so on. Yes?
So many students are asking Cikgu to hide the notification about of the meet.google.com is sharing a screen. Press hide.
Okay.
Because
Okay.
they think it's a nuisance.
Spoiling the view. Okay, how about this one? If I were to put here top, is it okay? Better go.
Yeah, just
Okay.
press hide. I also feel very nauseous looking at
Alright. Okay. Thank you. Sorry. Thank you. Okay. So, alright. Yeah, it is hiding the components down there. I'm so sorry. I thought it's only displaying on my slide, but eventually to you guys as well. Okay. So physical computing. So just now when Jiva mentioned about 1010 and so on, right? Okay. When we do basic electronics, there are like levels, yeah. Normally like simple level, we make it like in a block form, like in your microbit or in M block if you had tried this before, or Scratch. Scratch is more into programming, but when you want to program on Raspberry Pi, you can use Scratch. That is like a simplified version of higher level programming. So as it grows, ataupun as we delve deeper, you see this one, this is like an IC, a resemblance of an IC. So the output pin of each IC, it will be able to read your instruction as per syntax. It can only read the instruction like in 10 form. Okay. At the moment, those instruction, we call this as netlist, syntax, and so on, is being translated so that at this level, the chip can understand and give instruction to the components that is involved. Okay. All right, so this is an example. This is an example of this physical computing in which you have a system that interact with the real world, and typically we get information via sensors. You can have high-ended sensors, lower-ended sensors, and so on, which can, if a good quality sensor, they can give you real, near to the real value. Okay, and then from there, you can make a system that process this information. And from this information, it can either give it to a display or react to this situation via actuators. So when I mention actuators here, is something that is moving ataupun can give physical interaction with the environment. Okay. So having explained into that 4 items, I would like to explain a bit on this year technical track for Digital Ninja, which you guys will be divided into 3 clusters. The fundamental cluster, intermediate 1, and intermediate 2. Okay, let me go for the first one, the Arduino robotics. Okay, you remember during your first day, last Saturday, you fill up the screening form, right?
Yes.
Yes.
Right, okay. So from that training form, we have gone through it, and we look into the elements that we think that you might get the most from our trainings. That is why we are dividing you into different groups. So for the Arduino, we call this as fundamental Arduino robotics, is because that we feel like for a digital maker ataupun for a digital making process, having to know at least one open source platform programming language, as well as how to elevate you to another level of digital making. Okay, so then we clustered you guys into Arduino track, and then in this in the second track, which is the intermediate one, the 3D prototyping, you will go through a couple of modules in which how to visualize item and how to model, and as well as how to get involved in 3D printing and so on. Okay, for intermediate 2, we have this Raspberry Pi IoT. So yesterday I couldn't remember. I think there is one student who did project with Python, in which you can send WhatsApp, multiple WhatsApp messages via Python. So
Edison.
Is it Edison Lim? Yeah.
Yep.
Okay. So yeah, it's interesting. You are using this Python language. Okay. Similar to this Raspberry Pi unit, we can also program it using Python. And here you will learn on how to take some readings from sensors, and also to have it displayed via a website, and also an apps that will assist your project. Okay, if we were to look here, you see that there are two things here that is being displayed. The first one on my left hand side is the Arduino. Okay, some of you might have experience with Arduino. Some might not have this experience, but okay. And then the second one is Raspberry Pi. So I would like to explain a bit on the differences between these two. Okay, so basically Arduino for microbit. Okay, microbit, the one that you in primary school nowadays, microbit is quite popular. Is known as microcontroller. Whereas for Raspberry Pi, Intel Edison, Bigger Bone Black, okay, this one is quite an advanced version. It's known as microcomputer. So for microcomputer, it is actually something similar to the laptop that you are having now, in which quite complex and also detailed analysis. Okay. Whereby for microcontroller, typically we are dealing with more input, we call this as general purpose input output, which means that we can take control of more sensors and also more actuators and also motors. Right. So for fundamental, you guys need to have at least some exposure to microcontroller. Then for the intermediate 2 cohort ataupun intermediate 2 groups, we feel like you need to more into the analysis part. Hence, we are proposing this microcomputer, which is Raspberry Pi, as the track for you to delve into.
Excuse me, teacher. Sorry
So
for the interruption. Hello?
Sorry, are you asking something? Yes.
I'm not. Can I take this is because my school, my teacher calling me, so it's immediately. So because I'm at school, so please.
Okay.
Teacher,
Okay.
please give me.
Okay. All right. Okay.
Permission.
You want to? Okay. Yes. You want to excuse yourself? Yes. Okay. Okay.
Thank you.
So for fundamental, you guys will receive this STEMBot kit, in which it is based on Arduino. We are using Arduino Nano, and then from here you will have this propeller system, in which we have 2 motors and so on. You will learn the first it is like basic on how to communicate basically with your Arduino Nano here, how to give instructions, how to read how to read inputs. And then secondly, we will look into how you can control this robot, and how you can take readings from this sensor. We have a line sensor in front here, and how can you program this robot so that it can follow certain tracks. Okay.
Cikgu.
Yeah. Yes.
This 6 slots is only for the fundamental students.
Yes,
Yes
only
or
for
no?
fundamental. Yes, yes, only for the fundamental student.
And when we are getting splitted, not really getting splitted, when we will start attending the courses according to the cluster.
Okay, on September 11th until September 13th. September 11 until 13th. So
So it means,
slot number 2, September 11, 3 and 4, 12, 5 and 6 on the 13th.
so it means that we will be meeting and meeting each other until 10th of September.
Yes, yes, yes. What happened is that today you know your groupings, right? And you guys already know your sort of like assignment in this morning class. So you will continue to do that soft skill classes and also to brainstorm for the projects that you guys want to build. And on the 11th, 12th, and 13th, you guys will go through these technical slots in which you guys will learn about this platform, this programming, and how can you make use of this to develop your project. Okay. Okay. So I move on to the second part, which is the intermediate one part. So in the intermediate one, we 3D prototyping or rapid prototyping. So it will be covering from the 3D printing module up until design thinking from the perspective of 3D printing, yeah, and then design for additive manufacturing. Now, just roughly would like to ask you guys, do you know additive manufacturing?
Yes.
Additive manufacturing is like
What is that?
is one of the main component of the 4.0 industrial revolution.
Okay, one of the pillars of 4.0. Okay, can I have Dr. Isma here? Is Dr. Isma here?
Yes, I am here.
Okay. So so Aaron, just now Aaron, if yeah, it is one of the fourth IR pillars. So what is that?
4.0 industrial revolution is like the insurgence of electronics and internet, and there are 9 main pillars like IoT, big data, cyber security,
Okay.
manufacturing.
All right. So okay, I would like to ask a bit more. What is 4.0 revolution? Fourth industrial revolution. Or anyone else? Yeah. Please.
4.0 revolution is, from what I understand, is the application of technology, technological advancements like artificial intelligence into our industrial life. Like 1.0 was machinery. It was only machines.
2.0,
Yes.
1.0 machinery. Yeah.
2.0 also.
And the products are produced in mass. And 3.0 is the insurgence of, is the, what is it? The kemunculan. Kemunculan in English is what? Kemunculan.
Revolution kot,
Yeah, it's something like.
Kemunculan is like the kemunculan of computer and internet. And this is when the digitalization and automation was introduced to the world. And for 4.0 is the mixed combination of mechatronic elements.
Okay. Mahesh, just now you are telling something. Can you tell us again?
Yeah, actually, like Aaron said what I wanted to say is basically like industry 1 and 2 is basically still machine, but then when it came to 3 we were exposed to like technological CPU chips. It's like 3.0 where we started making big steps in the technological world, and then 4.0 came, and 4.0 is like an idea where everything is mostly automated. Machines are doing the job we need to do. Like they are helping to assist humans in like a higher level.
Okay. All right. Thank you. Aaron and Mahesh mentioned mentioned several things that I think I would like to elaborate. I think it is nice. You mentioned about automated. You mentioned about mass production. You mentioned about talking to each other, IoT. Okay. Other than that, does anyone else want to have a shot on what do you think about IR 4.0? first, second industrial revolution. Mahesh just now mentioned that it involved mechanization. Yeah. Third, it involved automation. Fourth, it involves IoT or interaction between machines and computers and so on. Okay, so if you were to go to any like industrialist or any industry that is evolving now, one word that always mentioned when we talk about fourth revolution is that I thought at first it is like automation. Okay, but one word that they mentioned is about customization. Okay, as you mentioned just now, in the first revolution, it is a mass production, which means that kalau dulu, if we were to produce something only like one or two, then in the 1800 we start to start with the steam technology and so on. We start to have these machineries to start on, and we start to produce items production in mass. Okay, but what happened is that customization is quite difficult at that time, right? And then we move on into automation. Okay, when we talk about automation, there are two elements that is very relevant to you guys that you can start to build up the skill. The first one is electronics or electrical. The second one is mechanical or mechanization. Okay, automation, mechanization, and so on. You must be able to be able to program, to be able to make production that could suit these two items. Okay, but when we talk about fourth revolution, which means that it will give you freedom to control something from far away, to monitor something from far away, and so on. So that involves another one more element here, which is communication, which means that you are allowing machine to communicate between one to another. And with that communication, you can do a lot more of prediction, you can do a lot of maintenance and so on. So what does it has to do with you guys is that those kind of workforce ataupun those kind of skills are required, which means that when you are in school, not only you need to excel in your academics, but also you need to possess these kind of skills. When you want to give instruction to machines, more or less something similar, you give instruction to computer and so on. So conceptually, even though you could say attractive 3D products, yeah, even though you are developing project small scale, but the skill that is required, for example, you to have cloud and to control the cloud and so on, to push the information to the cloud and to get it displayed and so on, is much relevant to the fourth industrial revolution. Okay. All right. So, Dr. Isma, would you like to add something in your intermediate one course? If you could walk us through to the modules that these students will go through.
Yeah, for sure. So basically, for this course, it's not going just learning about a design, but we involve with maybe a little bit introduction about 3D printing, what is the application and how's the process, and maybe show you some example with the current application. And then we're going to dive a little bit about the design thinking. So before we do something, so we need to have a strategy how to design, so how we can came up with our prototype. And then for module 3, we're going to maybe go through about the DFAM. Actually, it's about design for additive manufacturing, where you learn about the limitation using a printer, and then material selection, and then how to use a slicer before we can start to 3D print. And then module 4, you're going to learn about 3D design. For this course, I'm just going to give an intro using a Tinkercad. And then module 5 is on mini project. So I'm going to give a short theme, and then we're going to do a project with the use of design thinking. And for module 6 is going to be your project actually. So for module 6, you're going to start what we call it, try to design for your own group project.
Okay, thank you, Dr. Isma. Just now, we were talking about additive manufacturing before we spent quite some time to discuss on the fourth IR. So, additive manufacturing, what does that mean?
Google.
Okay, Google. All right. Okay, say for example, in the shapes that we have on the right hand side here, okay, typical process, if it is not using this additive manufacturing technique, how do we normally do these kind of shapes? How can we
Mold.
manufacture?
By molding.
You're right. Using mold. Okay. Betul Dr. Ismail? When we use mold, thank you for the one who answered just now. So when we use mold, it involves injection and so on. So typically when we want to change the shapes and so on, means that we need to change the mold. Correct? Right? So some
Yes.
minimal changes and so on, it is not that lenient. We don't have that kind of freedom. We don't have that kind of customization. So additive, Dr. Ismail, betul additive is to make this little by little, adding bit by bit, that it can become some object ataupun product. Okay, you will go through this module in detail, right, Dr. Ismail?
Oh, betul.
Okay. So then you will go through this Tinkercad model, and towards the end, you guys will be developing a project in which we will print it out for you guys, and later on, you guys will do that in your project, in your Ninja project.
All right.
Okay. Right. So Dr. Afif, is Dr. Afif here?
Ada.
Okay, Dr. Fatimah kalau ada sekali. So another one more slots which is intermediate 2 is Raspberry Pi IoT. Dr. Afif, would you like to go through the modules that you will cover during these technical slots?
Okay, boleh insyaAllah. Okay, bismillah. Can you hear my voice?
Yes.
Okay. So we have 6 slot, and the last slot is for clinic. Okay. So here I will explain about the first 5 slot. So for the first day, slot 1 and 2, you will open, or maybe you can open it earlier, but we will I will explain about Raspberry Pi. Okay, so we will set up the microcontroller, and also learn basic unique Linux command, and also Python, basic Python. And for the evening slot, the second slot, we will connect the sensor. There are several sensors that will be sent to your home. So, and for the first and the second slot is I will deliver it, and another person, Dr. Fatimah, will share with you for slot 3 until 5. Okay, so for 3 we will stream the data that we got from the sensor to cloud or to web application. Okay, for the slot number 4, we will customize dashboard lah, okay, online dashboard, okay, using some web application. And for slot number 5, we will learn about how to communicate with Raspberry Pi from the cloud, okay, from the from the website. Okay, so Aaron, you are in our group.
Yes.
Okay, so see you next 2 weeks. Okay, Dr. Nurul, that's all.
Okay. Thank you, Dr. Afif. Okay, just now I've shown to you guys the differences between Raspberry Pi and Arduino, right? So even they look quite similar in a way. If you were to see, both are being made on top of okay, both are being made on top of this PCB board, but it is actually two different items. One is microcomputer, the other one is microcontroller. So like Dr. Afif mentioned just now, microcomputer here, Raspberry Pi, you can actually build higher level kind of project. So the emphasis at this stage is to walk through into data visualization, data streaming, and so on, and I'm getting feedback. Okay, Dr. Afif, experience is in image processing, betul?
Yes.
Okay, so while you are taking this course together with Dr. Afif, together with Dr. Isma, you can always ask about their PhD, their research project. Because I remember we went to a school in which Dr. Afif shared his experience doing this data processing or image processing. I already forgot, but something to do with the processing. It's interesting to see how this interrelate to advanced project. Okay, you may start, it may seem like a simple project, taking something, showing, storing it and having things speak to display things and so on. But these are the base for you to do complicated, complex project and so on. You may want to explore what is machine learning and so on. Okay, during the breakout session later, you may ask these instructors and also mentors.
What is a breakout session?
Okay. After these two more slides, we will go through. We will be. You guys are going to be divided into 3 groups according to your slots. Okay. The breakout session, which means that I will break you guys into these 3 slots: the fundamental slots, intermediate 1 slots, and also intermediate 2 slots. Okay. So Kamil, is Kamil here?
Yes, can you guys hear me?
All right, okay. Kamil is one of UMP students, and Kamil will be the one who will be mentored you guys in order to do this Arduino project. So Kamil, if you could walk us through into this content, into this slots content when they go through these fundamental courses, what will they be exposed to?
Okay, Assalamualaikum and good evening. So we will start like in the with the basics, which is like digital output. We try to light up an LED using Arduino, and then try to blink the Arduino. Blink the LED, and also how to, in analog input we are trying to read real world data and display it on the screen. Okay, that's for slot 1. So for slot 2, we are going to be more advanced. We are collecting the data and also controlling the output. So what we are going to do is we're going to read the IR sensor data, which is the infrared sensor. And if the sensor detects something, we are going to light up an LED. We will go deeper into that in the slot itself. And then the next one is we are trying to display something on the OLED screen. OLED screen is a very small screen, which is usually just one color. And it is on the robot that if you guys can see on the slide there, yeah, like Dr. Nurul highlighted that one. So how do we use that thing? And then in slot 3, we are going to play around with some stuff, which is firstly using the ultrasonic sensor, which is to measure distance, right there. And then also time movement. Time movement, we are going to use motors and pretty much use motors to move the robot itself. And then that is just like we are telling it to move forward, to spin around and move backwards, and that's it. But then in slot 4, we are going to make the robot follow commands such as follow the line and also choose junctions in slot 4. And slot 5 and slot 6, we are going to make some free time to do the activities that are done in the slot previous slots, and depends on the mentor and the group itself. I think that's it.
Okay. Thank you, Kamil. So basically, these 2 slots, we sort of like reserve these slots. We would like to see how you cope with the content that we provide to you guys. If let's say you can do this assignment ataupun you can finish this activity in before time, we are thinking of adding a little bit in depth in which we are going to introduce you into PID controllers. So when we mention about, anyone here who has participated in robotics competition such as line following or obstacle avoidance?
I have.
I have.
Yeah. Okay, Saam.
I have.
Okay. Okay, good. What competition did you guys compete in?
Make X.
Make X, okay.
Yeah, make X also.
Basically, you guys use make
Tracing. Retro science.
Retro Science, RBTX, okay.
Retro science.
Retro Science. Sorry, again, Arif, tadi siapa Haikal? Sorry, Drabot, okay, Drabot, okay. Alright, so RBTX, okay. So if you went to RBTX last year, there are this line following. There are also
NRC.
on NRC, okay, National Robotic Competition involve Lego, okay. Alright.
Very good.
Okay. So okay, come back to this competition. Okay. Now one of a typical robotic competition that is line following, right? Wherever you go, kalau ada robotic competition, they will involve line following. How well the robot could follow lines and so on. Okay. The challenge follow lines is how can you make if the line is having very sharp turn, yeah, like 90 degrees turn ataupun a very sharp such as 270 turn, how can the robot perform it with minimal disruption ataupun with following the lines very accurately and so on. So in order to do that, you can do typical programming such as based on whatever input that you got from your IR sensor, and from there you generate logic diagram. From that logic diagram, you choose whatever, whether the motor needs to turn to the right or turn to the left and so on. Kan? Okay, tapi there are certain concepts such as PID controllers in which you are taking real data information and make decision based on that so that you can achieve much more accurate positioning and so on. So if you guys could do that on time, okay, we will use this slot number 5 and slot number 6 to introduce you guys to the PID. Okay, otherwise we will follow this and so on. Yes, is there any question just now?
What is free flow?
Free flow, free flow is that this is basically like free space, free time, depending on your progress. If you can do this within time, we will introduce new modules. If you couldn't finish this during this given slot, we will use this slot number 6 to recover whatever that you cannot finish. Okay, here, if you look here, this is a website to a video, this is a website whereby we had uploaded a couple of videos relating on how to do the programming for this robot. So I believe next week, MDEC will start to send you guys the kit. Okay, you can start to watch this video roughly after the Merdeka Day, maybe like September 1st, 2nd or 3rd. If you have already received this kit, you may want to go to this website and try to explore this. If you have any trouble, just let us know. And during the slots, we will go in depth into each and every activity. Okay, so what we will do now is that, okay, after this, we will go into breakout session, which means that if you are in track number 1, which is the Arduino track, you will use this code as your class code to enter the Google Classroom. Okay, for Tinkercad, this is the code, and for the Raspberry Pi, this is the code. Okay.
So it means that I'm in intermediate 2, so I should use YJA3W.
Yes, correct. So during the classes, we would really appreciate you to be ready before class. Okay. So if you see the class is actually number 2. The number 1 thing is that before coming to this September 11th class, make sure that you have the right devices, in which I hope you have your PC or a laptop, Okay, if you are in Arduino track, make sure that you already have your Arduino installed. Okay, if you are in the Tinkercad, make sure that you have the access to the internet so that you can log in the Tinkercad. Okay, if you are in the Raspberry Pi, make sure that you have the access to the Raspberry Pi, Raspberry Pi. What are the software that is you? What software, Dr. Afif?
No need.
Cikgu.
Tak perlu, tak ada software, tak perlu.
Tak ada. Oh, just masukkan saja. Okay. Make sure that you are ready with your computers and so on, and also the learning kit. So for Raspberry Pi, make sure that you have your learning kit. Okay.
Yeah, learning kit and a computer with you.
learning kit and also computer, and also we will go into electronic components. So make sure that you have that in hand before class. So for the Arduino class, make sure that you have your STEM board with you, and then make sure that you are connected with Wi-Fi. Then you can come into the classes, and don't forget to check in the attendance. And those learning materials and also assignment learning materials can be retrieved via this Google Classroom. And also whenever from time to time, we will give you assignments for slot number 1 or slot number 2, which is basically maybe to update whatever that you have. Make sure that you submit in this Google Classroom. Okay, so for our meeting, it will always be for this breakout session later. Okay, we will use this meeting room, and these are the links for the rooms that we are going to have. Okay, so before we move on to the breakout session, is there any question?
Hold on. Cikgu.
Yeah. Yes, Aaron.
How to download the Raspberry software, and when we are supposed to get our stuff ready?
Okay.
I think
As I understand, next week, okay, please update the link that is being sent to this WhatsApp group, in which they are requesting for your address. If I'm not mistaken, next week they will start to deliver to your house. So basically, before the class, before 11th, you will get the kit. Okay, yeah, for Raspberry Pi, you don't need to download, because you are going to use that Raspberry Pi as your main processor, mini computer.
So how to download the Raspberry software?
You don't need to download. You just need to plug in. You just need to plug in your Raspberry Pi to the monitor, and then from the monitor together with your keyboard, and from there you will do the programming and so on. Okay.
Cikgu, I have typed the HZW7NRSK03 cat. There's no link.
Yeah, because I have not activated that yet. Okay, so just now Hazim asked how about Arduino. Okay. So for Arduino, once we are in the breakout session later, we will guide you on how to install Arduino, how to download Arduino basically to your computer, and from your computer how to install the Arduino software. Okay, we will do that in a bit time in the breakout session. Okay.
So can we leave to our respective course?
Yes, you can. But wait for a moment. I would like to see if there are any questions that we can address before we go to the breakout session. Just now Mahesh has already shared. Yeah, you can go to Arduino CC. From there, you can download the Arduino.
And for the Raspberry, we don't have to do anything. Just
yes, you don't have to do anything.
Make homework. Yes or no?
Yes, you wait for your kit to arrive. Then from there only you can start to do your project.
Can I ask a
problem?
Yes, Zen, you asking something?
Right. So first of all, is the Raspberry Pi coming with a SD card preloaded with
Yeah, the Raspberry Pi will come with the card. Okay. The only thing that we will do a survey later on. Yeah, Dr. Afif, we will do a survey because we want to know whether you have monitors and keyboards or not. Okay, because in order to do the project, the whole complete set is Raspberry Pi, keyboard, monitor, and also mouse. Raspberry Pi will be delivered together with the micro SD card, so you don't worry about that.
So for the intermediate 2 students, what are we getting from the Ninja Kit?
The kit is expected to be delivered next week. So when exactly you will get, I am not sure, but I hope before the class.
I mean, what are the Ninja Kit components for the intermediate 2 students?
Okay. For the intermediate 2, the kits will consist of these components. You will get, alamak, kecil bit here, wait lah, let me zoom it. You will get this item, you will get Raspberry Pi 3.0 together with the micro SD card. You will get some electronics components. Okay, you will get also At the moment, those two are confirmed. We will make a survey later on to see how many of you guys have keyboard and also monitors and so on. That one, we are not sure whether you guys will be delivered, or if you have your own, then you can always plug in together. So never mind about this. Nanti in the breakout session, your instructor will come into the details of the survey. Okay?
Alright, no problem. So
basically you will get this Raspberry Pi. Sorry.
So I have no questions for now. Can I leave?
Yeah, you can leave, and later on you can come into this breakout session. Yeah, give us around 10 minutes break, then you can come into the breakout session. For those others who have any other questions, yes, then.
Where will the code posted?
Where will the kit posted or the code posted?
The code for the breakout session.
Okay. It is already now here. Okay. Let me copy this one. Wait, Zen. Let me copy this and nanti it will be easier.
Can you put it on the WhatsApp group?
Yeah. Sure. We can. I can. Yeah.
Okay.
Wait, yeah. One moment. So DNAL Ninja. Yeah. So this is the breakout codes. Okay, the one that I mentioned now. Okay, I already passed it here. You can have a look here. Okay. So okay, Muhir. All right.
Yeah.
Zen.
May I ask for the Raspberry Pi, the Raspberry Pi one? Are we allowed to use our own Raspberry Pi?
Yeah, if you have, you can.
Right.
You have which version of Raspberry Pi? 3, 4?
4.
4. Okay. Can.
So we have a 10 minutes break, and after that we can participate in our respective cluster link.
Yes. Okay. Let's meet 3. Okay. Now it's 3:46. Okay. I'm so sorry. I apologize. Let's meet around 4 in the breakout session. 15 minutes from now.
So we have a 15 minutes break, and 4 p.m. we will leave this link and link up with the cluster link.
Yes. For those who have questions, you can keep asking question. For those who want to leave this session, yes, you can leave this session. Okay. Then come back to the right track later on at 4.
All right, no problem. Thank you. Bye.
See you later. Okay, bye. Okay.
Thank you, ma'am. Bye.
Thank you. Okay, again, I have here 79 attendees, but now we have around 92 minus around 5 UMP stuff. So we are expecting around 87 attendees. So if there are any of you guys who has not filled up this attendance form, please do so before the breakout session. The link to the breakout session I've shared in the WhatsApp group. Okay, the code. All right. Okay, let me skim through last.